Okay, so let's get started. We're going to be taking a look at setting up our pulse width modulated type of outputs from our Motec M1 systems. Now, a pulse width modulated output will differ from an on-off output because we're going to be sending a pulse to our device that we're trying to control. We have a lot of advantages with a pulse width modulated type of output. It opens up the ability to control a large variety of devices. We'll find pulse width modulated solenoids could be something from an idle control solenoid, boost control solenoid, variable valve timing solenoid, cooling fans, the electric water pumps, fuel pumps. So those are among some of the more common things that we could pulse width modulated control from our Motec. So we have to go through and understand some of the fundamentals with a pulse modulated control. There are some bit more complexities programming and setting those tables up and the conditions up for a PWM's type of circuit compared to an on-off circuit that we talked about in our last training module. We're going to go through those basics here in the beginning of this training tutorial, and then we'll move into some specifics of setting up two different examples here of a pulse width modulated type of control. So first thing I want to talk about here when we're talking about pulse width modulated outputs is the difference between a low and a high side output. This is very basic, but also very important to understand because it will dictate how we wire our device to our Motec. So for example here, if we're talking about a pulse width modulated output, that's going to be sending a pulse to the device. Now a low side output is going to be sending ground pulses to the device. So let's say in the situation where we're directly driving and controlling a electric water pump from our Motec, we can find we would use a half bridge output. Those have a little bit higher sinking amperage compared to low side output. We'd be able to go in and just simply pulse to the electric water pump low side, and we'd find on the electric water pump we'd have two wires. Traditionally solenoids or pumps have two wires. One wire would go to ground, one wire would go to power to traditionally power up that circuit. With a pulse width modulated, we would send power to the device, but we're going to be pulsing the ground side of that device to energize the circuit. So a low side format would be pulsing to the device in a ground type of pulse. When we're talking about high side, we'd be doing the opposite. So the device, let's say electric water pump we're trying to control, we would ground the device and we'd be sending 12 volt pulses to energize the circuit in the device from the half bridge output. Half bridges do both low and high side, and we'll talk about that here a little bit more as we discuss some of those details. But we'll find that we would send a high side output, we'd be sending the 12 volt pulse. So the difference between low and high side 12 volt pulse, low side ground pulse. Pretty basic. Now, let's talk about a couple additional things as we're on the topic of pulse width modulated control. Anytime we're programming a pulse width modulated circuit, we're going to have to specify the frequency as we're sending those pulses out to the device. And then we're also going to have to specify the duty cycle we're trying to control that device at. So we can think of frequency as the amount of pulses we're sending in a given amount of time. Usually it's going to be a 1 second time interval. If we have 10 pulses, that would be 10 hertz. 100 pulses would be 100 hertz. 1,000 pulses would be 1,000 hertz. Things like drive-by-wire servo control with a half bridge output, those will control in this pulse width modulated type of format. You may find a few thousand hertz to control and pulse to a drive-by-wire throttle body. But if we're talking about something like a cooling fan, you may find it only needs 100 hertz or 100 pulses in a second. So there's going to be a frequency that a device needs to be controlled at. The manufacturer of the device should be able to tell you what the ideal frequency to control that circuit or that motor at. Very important that we know that. Now, the duty cycle, what does this actually represent? So the duty cycle is going to be how long we're commanding that particular device on for. 0% duty cycle means that the device is off. 100% duty cycle means that we're driving it 100% of the time or it's fully on. 50% is going to be controlling that, with 50% going to that circuit or that motor. So it's going to be, in the case of an electric water pump, spinning that motor much slower at 50% duty cycle compared to 100% duty cycle, what that would be full flow. So we have to kind of keep that in mind. The frequency is what we drive or pulse the device at. The duty cycle is how long we're energizing within a certain period of time that device, and we need to specify both in order to have things controlled properly. So those are some of the fundamentals to get out of the way to understand pulse width modulated control. Now let's jump in and take a look at setting up an electric water pump. We were just on that topic. So we're going to move in here and look at some of the programming conditions and some of the things that we have to be accounting for in order to control an electric water pump properly. Let's go from our tuning window here in the workbook I provide. Let's go into our setup area here and go into the all calibrate option. This allows us to jump in and take a look at any of our outputs fairly easily. I'm going to move down my list here and go into coolant, and then I'm going to go here into, in this case, pump. This would be electric water pump. Now the output resource is something I need to select. How am I going to wire my electric water pump? Now, we can find here, we have some options. Half bridge.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.